everyone, we're doing a worksheet on exponential growth and decay. So it has one formula that we need to memorize and understand, that is exponential growth equals to initial value and then 1 plus r over 100 raised to power t, or if the question is about decay, we'll use exponential decay here and minus sign here. So if it's a question on exponential growth, we'll use the sign positive sign. If it's a question on exponential decay, we'll use the negative sign. So starting with question number 1, you'll understand this formula properly once we start the questions. Alright, Newton has a population of 23,000. The population decreases exponentially at a rate of 1.4% per year. Calculate the population after 5 years. So we have to find the growth after 5 years. So equals to initial value is 23,000, initial population 1. Since it's a question on growth, we take the positive sign. Rate is 1.4 over 100 raised to the power t. Time is 5 years. So simply enter all of this in your calculator once and get the answer. So let me rewrite this with a little more clarity. 1 plus 1.4 over 100 raised to the power 5. When I'll enter all of this in my calculator, I will get, the question was on the population decreases exponentially. So I was supposed to use the negative sign, not the positive sign. The population is not increasing, it's decreasing. So the new value or the answer would be smaller than 23,000. So when I'll enter this in my calculator, I will get 21,434.4532, and when I round this off to 3 significant figure, this becomes 214 and 00. So this is the answer for question 1. Question 2. There are 30,000 lions in Africa. The number of lions in Africa decrease exponentially by 2% each year. Find the number of lions after 6 years. Give your answer correct to the nearest 100. Alright, so again it's a question on exponential decay. The initial value is 30,000. 1 minus rate is 2 over 100. Time is 6 years. Enter this in your calculators and you will get 26575.27143. Round off to the nearest 100, so the nearest 100 will be 600. 26600 is the answer for question 2. Question 3. The population of Alton is decreasing at the rate of 3% per year. In 2013, the population was 50,000. Calculate the population after 4 years. So initial value is 50,000. 1 minus rate is 3 over 100. Time is 4 years. This will give 44264.6405, which becomes 44300. Answer for question 3. Okay. Question 4. Robert buys a car for 8,000. At the end of each year, the value of the car has decreased by 10% of its value at the beginning of the year. Calculate the value of the car at the end of 7 years. So we simply substitute the values. The initial value is, or the original value is 8,000 over 8,000, and then 1 and minus or plus decreased. So minus rate is 10 over 100 power 7. So the answer is 3826.3752. Okay. Although this is the exact answer given in the marking scheme, but I guess even if you round it off to 3 significant figures, this answer should also be accepted. Okay. Question 5. In a city, the population is increasing exponentially at the rate of 1.6% per year. Find the overall percentage increase at the end of 20 years. Okay, question number 5. Rereading it. In a city, the population is increasing exponentially at the rate of 1.6, and find the overall percentage increase at the end of 20 years. So we don't have the original value, and we even don't have the value after 20 years. So what we can do is either we can incorporate algebra in it, use x, etc., but instead what we'll do is use 1. So if this initial value, let's say, is 1, let's find this. I'm not using x to avoid involving algebra in this question. Instead, I am using 1. So I'm saying my initial value is 1. So when I enter this in the calculator, I get 1.3736, and more, there's more, 4, 3, and so on. So this is the increased value, and this was the original value, and this is the new value. Now how do we find percentage increase? Increased amount over original amount. So how much has it increased? In the numerator, it has gone from 1 to 1.373643. So the increase is by finding difference of these two, and original value is 1 times 100. So this gives 37.36, and rounded off will be 37.4. So this is how you do it. Or you could use another method, and what you could do is ignore the 1, simply solve what you have. We have this, we solve this, this will get us 1.3736. So the next what you can do is multiply this with 100%. So this becomes 137.36%, and original value is always 100%. So subtract these two and you get 37.4% rounded off value. You could use this as well. Okay, question 6. Part 1. A new truck costs 15,000 and loses 23% of its value each year. Calculate the value of the truck after 3 years. So initial value is 15,000. 1, it loses its value, so minus 23 over 100 after 3 years, so power 3. Okay, so then let's find this value, and we get 6847.995, and rounded off to 3 significant figures, I guess we get 6850. Or here they've used 6848, which is rounded off to 4 significant figures. Alright, so you may use this or you may use this. I guess the answer should get accepted. Okay, part 2. Calculate the overall percentage loss of the truck value after 3 years. So percentage loss would be loss in the numerator. So how much have we lost? So loss is from 15,000 we have gone to 6847.995. Now we'll use the unrounded off answer. over original value is 15,000 times 100. So 15,000 minus answer, because the previous answer is still flashing in my calculator, divided by 15,000 times 100, I get 54.3, rounded off to 3 significant figures. So this is the answer for question 6. Question 7. The population, let me copy this here. Okay. The population of the world grows exponentially at the rate of 1.1% per year. Find the number of years it takes for the population to grow from 7 billion to 7.3 billion. So I'll use the new value here equals to initial value times 1 plus rate is 1.1 over 100 raised to the power t. Now I would use billion here and billion here because they would cancel out. Billions means 10 power 9 I suppose, and 10 power 9, 10 power 9 at both the sides of the equation get cancelled. Alright, now we need to make t the subject. So let's divide 7.31 with 7 and we get 1 point, in fact let's leave it like this, 7.31 over 7 equals 1 plus 1.1 over 100 raised to the power t. This becomes 1.04428 equals to the, this becomes 1 plus 1.1 over 100, so which is 1.011 t. Now what power of 1.011 equals to 7.31 over 7, or this decimal value? Next you just need to try a few values of t. Of course we can't, 1 won't equate these. Try t equals 2, 3, 4 and you'll notice that at t equals 4 you'll get left hand side equals to right hand side. Next up is question 8, which is, it is estimated that the world's population is growing at a rate of 1.14% per year. So on January 1st, 2014, the population was 7.23 billion. Find the expected population in billions on January 2020. So we need the population after 6 years. So initial value over 1 plus rate over 100 raised to the power time, and time from 2014 to 2020 is 6 years. So enter this in your calculator and we get 7.73884. Okay, so this will get rounded off to 7.74. This was 8 part A. Next, part B, find the year when the population is expected to reach 10 billion. So I'll write 10 here equals 7.23 times 1 plus 1.14 over 100 raised to the power time. So again I need to find the value of time. Okay, so we'll divide 10 and 7.23, which gives us 1.383125 and so on, equals to 1 plus fraction key 1.14 over 100, which is 1.0114. Now what power of 1.0114 will give us 1.383125? What do we do here? So again this requires some hit and trials are at our end. So start with value of t greater than 2, 3, 4, 5, 6 and so on, and keep trying till you get this value. You might have to make bigger jumps because you'll notice that for small values of t you're way far away from this question. So by many hit and trials you'll notice that at times equal 28 you're getting this value over here. So the value for time is 28, then you add 28 years to 2014 and you get 2042. You can also use the table option of your calculator and enter multiple values of t together. That will make your working a lot easier. Question number 9. At the start of an experiment, there are 20,000 bacteria. The number of bacteria increases at the rate of 30% per hour. Work out the number of bacteria after 4 hours. So, initial value is 20,000, 1 plus rate over 100 and time is 4 hours, which gives us 57122 for part A. Part B is after how many whole hours from the start of the experiment will the number of bacteria be greater than 1 million. So let's write 1 million over here, should be greater than 1 million. So this is 1 million and number of bacteria should be greater than 1 million. So 2000 1 plus 30 over 100 raised to the power t. So again divide 20,000 and 1 million. So 1 million divided by 20,000 is 50. So 50 should be less than 1 plus 30 over 100 raised to the power t, which makes 1 plus fraction key 30 over 100. This gives us 13 over 10. So now what should be the value of t such that the answer at the right hand side should be greater than 50? So we'll try a few values and we'll notice that 13 by 10 at 14, when time equals to 14, this expression is 13 over 10 power 14 is 13 over 10 power 14 is 39.37. Then at time equals 15, this would become bigger than 50. 13 over 10 greater than 15, which becomes 51.1. So the value is time equals to 15 for question 9 part B. When time is equals to 15, the value increases, the value of bacteria becomes greater than 1 million. Question 10. The population of Dubai at the end of 2012 was 2.1 million. Okay. This was predicted to increase at the rate of 6% each year. Calculate the predicted population of Dubai in million at the end of 2015. So again, initial population was 2.1 million. I'll ignore million and write that in the end. Then 1 plus 6 over 100 raised to the power, we're starting from 2012 and ending at 2015, so that's 3 years. Find this value. We get 2.501136, which is 2.50. Question 11. The population of a village is 64,100. The population is decreasing exponentially at the rate of R% per year. After 22 years, the population will be 2607. So find the value of R. So slightly different from the previous question. Now we have to make R the subject. So 1 minus R over 100 raised to power 22. Divide 2607 and 2607 divided by 6400. This gives me a value 0.4073 and some more decimal places. Now I need to make R the subject, so I'll take 22nd root of this value. So 22nd 22nd root of answer, which is, this is 1 minus R over 100 equals to 0.9599 and so on. I do have more numbers. Let's move this to the other side, 9599, with the remaining numbers equals to R over 100. So I'll do 1 minus answer times 100 to get the rate, which is 4. So rate comes out to be 4.00000, so it's 4. Okay. Question 12. The number of newspapers sold decreases exponentially. So 1 minus X% each year. Over a period of 21 years, the number of newspapers sold decreases from this to this. So initial value was 1763000 and the final value is 58000. Okay. Calculate the value of X. So pretty much the same question. First divide 58,000 and 1763000, then take 21st root of that. That would be equals to this. So let me do that. 58000 divided by 1763000, and then I'll find 21st root of answer. Then I'll take X over 100 to this side and I'll write 1 minus the answer I just got. 1 minus answer times 100, so that is 15.0057. So to correct to 3 significant figures, it becomes 15.0. Question 13. Over a period of 3 years, the company's sales of biscuits increases from 15.6 million packets to 20.8 million packets. The sales increase exponentially by same percentage each year. Calculate the percentage increase for each year. Alright. So, over a period of 3 years, so raised to the power 3, the company's sales of biscuit increases from 15.6 initial value to 20.8. Okay, and then the sales increase exponentially by the same percentage each year. Calculate the percentage increase. So 1 plus R over 100. So I guess we're supposed to find the rate only. What percent? So let's solve this. So that would be 20.8 divided by 15.6, then take cube root, which will be 1 plus R over 100. So 20.8 divided by 15.6, cube root of answer is 1.10640064, etc. minus 1 equals r over 100 into 100 will give me 10.06, which correct to 3 significant figure becomes 10.1%. Okay. Question 14. A bacteria population increases exponentially at the rate of r% each year, so 1 plus r over 100. After 32 days, the population has increased by 309%. Find the value of r. Now again, I don't have the initial value or the final value, so I could use x, but I want to avoid algebra, so I'll assume my initial value is 1. Let's increase 1 by 309%, so that would be 1 plus 309% of 1, which is simply 409 over 100. So this becomes 4.09. So now find r. So let me rub this. Okay. Find r. Take cube root of 4.09. Then subtract 1 from it and we'll get r over 100, and then multiply the answer with 100. So cube root of 4.09, answer minus 1, and answer times 100, we get 59.9. Sorry, not cube root, but 32th root, 32nd root. So this is 32nd root of 4.05. So 32 root of 4.09 minus 1 times 100 is 4.5%. So r is equals to 4.5%. Okay, question 15. Which is the population of a city increases exponentially at the rate of x%. So 1 plus x over 100 every 5 years. In 2060 the population was in 1960 the population was 60100. In 2015 this population was 120150. Calculate the value of x. Okay, so look, the words every 5 year is in bold, so the time is not 5 years here, it's increasing by this given rate every 5 years. So how many times will it increase from 2015 to 1960? So find the difference between 2015 and 1960. So that is 2015 minus 1960, that is 55 years. And how many 5 years do we have in 55 years? That is 11. So we write 11 here, and then we write 120150 here. So now let's solve this. So we get, in fact let me rub this. So we first divide the two values. 120150 divided by 60100, 1.9991 and other values. Then we'll take 11th root of this, which will be equals to 1 plus x over 100. Then we'll subtract 1 from it and take multiply it with 100. So 11th root of answer equals this. Then I am subtracting minus 1 from it and then multiplying it with 100. So I get x equals 6.5. I think we're done with the worksheet. Yes, we are. Alright, I'll see you next time. Take care.